we've got, I'm going to show just the basics, and then we can work on lots of practice. So the idea is that at the end of the course, you come out with a shiny app of your own. So we've got all of the materials, PDF and the code, again, in a GitHub repository. So take a moment and download or clone the repository at ISU. So follow this link, github.com DSPG minus ISU.
In the chat.
Yeah, let me try to get to the chat. There we go.
Thank you.
Sure. So then clone the directory onto your local machine. You can just unzip it. So download a zipped version and unzip it. And we're also going to be a lot in RStudio. So make sure that you've got an open RStudio session. And it doesn't really matter where that session is. You could use it locally. You can use Rivana, or you could also use this RStudio cloud project that's set up with all of the libraries that we need. It's going to take a moment for the cloning. It's pretty big. Okay, so generally the overview is we're going to have a first look at a Shiny app. I'm going to talk about the main aspects of a Shiny app, so inputs, outputs, and then elements of reactivity. So the question of how the inputs communicate with the outputs and vice versa. Then we'll also talk a little bit about layouts, and generally I really want you to get a lot of practice. So make sure to use those your turns. The idea for tomorrow is that we're going to have a look at leaflets a bit. So leaflets in Shiny, and then I would like to take the majority of the day for you to work on your project and the dashboard that you're envisioning for your project. So just the real basics. Let's make sure that we all have the correct installation for our packages. And one package that's really essential to make sure that you know which versions there are and you know what's going on is the package dev tools. So dev stands for developers tools. So dev tools, are you feeling empowered already? So dev tools is really the access to the nitty-gritty details underneath your R implementation. So make sure to activate that with library DevTools. If you get a message that that package is not installed or missing or can't be found, make sure to install it. You can either use the package manager in R, or you can use the command install.packages DevTools. Notice the quotes here, otherwise you'll get an error message about the object not being found. So install.packages in the console is going to trigger an installation of the newest version that's on CRAN for DevTools. So once we've got the DevTools going, how do we use DevTools? One of the most important commands there is session_info. And on the right-hand side, you can see a version of my session info, well, on the new machine. So on the new machine, I'm actually running the R version 4.0. And then you can see at startup, all of the packages that are started by name, their version, and where they come from. So you can see that on startup, everything that I'm loading is all on CRAN. So important parts is the version for R, relatively new. So anything 3.5 and above should be okay. You can see that the newest version of R came out just a couple weeks ago. This is a real new version of R, so that's why the first number is changed. Usually R updates that first number every couple of years, but the second number in here, those are the updates that come out about twice a year. So this overview tells you what packages you're running, and the important part for us today is the version here. So we want to find out what Shiny version you have. Let's see. So we need to check whether your Shiny version is installed. So try to run the command library Shiny in your RStudio console. The newest version of Shiny is 1.50, but at least as of a week ago. So check whether your version of Shiny is close to that. And if either the first command fails or your answer to the second question is no, not really, make sure to install a new version of Shiny using the command, just like with DevTools, install.packages Shiny. And I'll go into RStudio. Once you've downloaded the zipped file, there's a folder called Day 1. In that folder is a R project called DSPG R project. And so once you click this R project, your RStudio should look like this. And if you've just started up your RStudio, you can also see that in this greeting that you see here, the R version is shown as the very first line. And you can see that on the old machine, I'm actually also running a slightly older version of R. So that's last year's version, and that should also be fine. So as long as you've got R from this year or last year, you should be fine. So let's go through that your turn. Let's check on the Shiny version. Library Shiny. I get a warning message that Shiny was built under a newer version of R. That should really tell me that I should update my R, but it's going to be fine. It's just a warning message. And then with session info, I can find, oh, hang on, library DevTools with session info. I can find out which version of Shiny I'm actually running. But given that it's once the newest version of R, it's probably a fairly new one. So here's the session info output. All of the packages are sorted in alphabetical order. And you can see here, this is the Shiny version from, just a couple days ago, a week ago. So if you don't have that newest version of Shiny, that's totally fine. As long as it's a 1.4, maybe a 1.3 version. All right. So whenever something really unusual happens and you get an error message for code that you don't think you should get, make sure that you take note of your session info. One of the first things that you can always try is to install a newer version of the package that you're using and see whether that fixes the problem. If it doesn't, make a note of the session info, and then you can ask a little bit more informed for help, where you can say, well, I'm running this version on this operating system with these packages, and this is the error message that I'm getting. So it helps other people a bit trying to figure out what's going on with a particular error message. Okay, so let's get ready for today. We've got Shiny running. So let's have a look at our first app. Are you excited? I hope you are. Okay, so we're going to create a new Shiny app in RStudio. We're going to run it, and then we'll also have a look at how to get out of it. So let me first show in the slides what you're supposed to do. And let me quickly check. Okay, so if you're still having trouble cloning the folder, rely on it. It's going to come eventually. All of the PDFs are in the folder, so you can catch up with us once you actually have the PDF downloaded. Okay, so I'm going to talk through how to create the Shiny app just in the slides, and then we can do it together for real in RStudio. Okay, so the nice thing is that RStudio is really supportive of creating new Shiny apps. So if we go under new file, and then under the new file, go to just the section Shiny web app, we're going to get a dialog window that looks something like that. The operating system determines a little bit on how each one of these dialog boxes looks like, but the functionality is the same. So what we need to then figure out is we need to give the application a name. So this one's called My First App. Then we have to have a choice between a single file and a multiple file. I would prefer to go with a single file. It really doesn't matter that much, but with a single file, everything is just in one file. And then we have to figure out where to put this new app. Your system is going to look different. I've got a folder called DSPG, and that's where I'm going to create that new app. So once we hit create, we're going to get back to our studio. In our text editor, we'll have a file called app.r. And this app.r is part of the folder, my first app. What's really neat is we can just say run this app. And what should happen is after a moment, we get this additional window. Just in case, what you get looks like this. So there's essentially nothing happening, but there's some red text showing up in the console. That's usually when the Shiny app lost the fight of control from RStudio. RStudio and Shiny both want to have control. And essentially what happened is that the Shiny app window built behind the RStudio window. So we need to we can open the Windows dialog, select the Shiny app, and that's going to make the Shiny app pop up in front of the RStudio viewer. So that's super confusing at first when something is supposed to happen and nothing really happens. So make sure that that you're not just missing it because it's behind the RStudio viewer. After a while, you'll get used to that, and you'll automatically check behind the RStudio viewer in case you can't see your app. Okay, so then we're in a place where we can actually interact with the app. So let's actually do that in RStudio and just go through that process for real again. Okay, we're in RStudio. We want to create a new app. What were we supposed to do? File, new file. And here, number 4 for me is Shiny Web App. Depending on how old or how new your RStudio version is, there's sometimes a couple more items in this menu. So let's select the Shiny Web App. And we've got this interaction dialog, my first app. We create this thing in a single file. And by default, it's just going to be created in the folder that we're currently in. So that might look something like this for you. So training, Shiny Web Apps, day 1. That's not the worst place for it. We create it. And you can see that now we've got an additional item here in our documents. We've got app.r showing up in our text editor. And we've got the option to run this app in the buttons up here. So we can either just hit the green triangle, or we can select between a variety of things. The default is just fine. We want to run this in a window. We hit run, and you can see that in the console, the command run app is pasted, and the RStudio window pops up. And in a moment, the Shiny app should show up as well. We've got a slider here and a histogram. Depending on how wide this window is, the layout's going to be a little bit different. We can move the slider, and by moving the slider, we trigger an action here in the plot. So number of bins, really small. We only have 4 bins here. Now we can see the 2 modes in this is the Gazer data, Old Faithful. So number of minutes between outbreaks of Old Faithful. It looks like it's a 2-modal distribution. If we go way up, we can maybe spot a 3rd mode here, but that's a little bit up for a debate. But there's 2 modes for sure that we can see by using different sets or by using different bin numbers and investigating that distribution. Okay, so this is our first Shiny app. And once we've interacted with it a bit, we might want to get out of it. So one thing about this is if we just go back, so I'm just going back, I'm going to click on my RStudio window. So I'm not doing anything to this Shiny app, I'm just going back. And what I said about RStudio and the app fighting for control shows up here. So we're here in this console and I'm trying to type. I can type, but R is not reacting to it. So when you have a look at this message, listening on HTTP, so it's actually listening to the RStudio, to the Shiny app dialog at the moment. In order to stop that, I have to either click this stop button or I go back to the Shiny app that's hiding just behind, and I'm stopping that Shiny app by just closing that window. And at that point, my console gets control back. All of the returns that I hit here are now showing up. This, obviously that object doesn't exist, but only now are those things that I entered into the console being evaluated. So until then, until I closed the Shiny app had full control and the console did not get any input through this text. Okay, so we need to make sure that we consciously close an app when we're done with it. So the question is, this seems a bit like magic. So how does Shiny really work? Essentially, a Shiny app has 2 parts. The thing that we see and that we interact with, that's called the user interface. And that is some sort of layout where we see user inputs. So those widgets, a slider, maybe checkboxes, a text that we could potentially enter. So those are inputs where the user's involved. And then there's outputs. So things that have to be built by the system, for example, a table or a plot or some additional text that's determined by our user input or depends on it in some way. So all of those would be outputs. So all of that is part of the user interface. And then we've got the glue underneath. We've got a server component that determines what happens between the user inputs and the app output. So you can think of the input as being driven by the user and the output being driven by the app. And the server part is really what the app is doing. The user interface, the UI, is how the app looks like to us and how the look. So it's a look and feel. And the server part is the actual work, the action part. So we can have a look at a minimal app. Let's try that again. There we go. So here's a minimal example, an absolute minimal example of how an app looks like. We need the Shiny library. We've got a UI. We've got a server. And we bind these two pieces together with the call Shiny app, UI server. So what goes into this UI? Fluid page is a command that creates a minimal HTML page. So the UI is essentially nothing but an HTML page. And then we've got a server, and the server is a function of the input we get, the output that's supposed to be created, and then the session info. And this is already a Shiny app. So we can go into our studio and actually try this out. So minimal amount of code. So we can either type this out, okay? Check the chat. Okay. So in the R code, you can see a lot of R files. Essentially, those R files are going along with the training today. And in case you get lost, or in case you don't want to type a ton of stuff, you can just select one file after the other. So 0, 1, minimal is almost the minimal example. We don't need the Shiny dashboard. So we can run this by either selecting everything or by hitting the command run app. So here we've already got some output. So you can see that in the Fluid page, I've added a mini HTML command, H1, for a large header or just a title. Hello world, this is me. If there's nothing in Fluid page, it's a very boring page. It's a very boring app that only has a white window. But you can see that it's an app. It stops the console. The console is now listening to this. It just doesn't do a lot. So let's put that back in. The server in this example doesn't do anything. The server just has to be there. The server has to be a function so we can have a look at what this function is doing. So we run this, and then when we have a look at server, you can see that this is a completely empty function. So it's not doing anything because we don't have an input, we don't have an output, we just have some text. And there's really a lot better ways to produce text in a window than this. So we can run this just for fun. And you can see that this text will show up. The rest, so H1 and H2 are just a little bit of formatting. H1 is a large header. H2 is the second largest header. You just include text. The text will show up in that window. Is there a question, Heike?
Oh, sorry, I didn't realize it was.
Okay, never mind, it's fine. Okay. So this fluid page is nice, but it's pretty atrocious, right? So let's hop into minimal 2. It's going to be an empty app still, but it's going to look so much better. So here, let's run it first. This is a so-called dashboard. I'll open it in the browser. In a dashboard, we're going to have a header along here, a sidebar on the left, and then a body, a dashboard body here. So let's stop that. How do we create this? Instead of fluid page, so it's all happening in the UI because it's just the look and feel. We haven't included any inputs yet, no outputs, so it's completely simple. We're just changing the user look and feel from fluid page to dashboard page. We create a header, we create a sidebar, and we create a body. And just notice how these functions start with the keyword dashboard, and then in camel case, so camel case because we start with an uppercase letter on the next word. In camel case, we add header, sidebar, and body to this. So the UI for that is an HTML page, so we can actually have a look at this object UI. And you can see, so for those of you who know a little bit of HTML, we're defining a body. We've got a header. We set up a navigation bar. We've got here, this is still the sidebar, and then we've got content. So all of that happens in these functions in R. The nice thing is we don't need to know anything about HTML. It's just being created for us, so we don't have to think about it. The only pieces of code that we need to know are these 3 R commands. And that's really the beauty of Shiny. We can still program in R, but we're creating HTML and CSS and some JavaScript in some cases. But we don't need to know anything about that. So the idea is that we can take our analysis, we can take our data, we can put it into a format that looks nice, and then leave it to somebody else to actually optimize things when this app is supposed to be official and go into some sort of production process. Okay, so we've got a minimal dashboard. Let's create a little bit more. Lara has a really good question. Shiny dashboard is still under pretty heavy development, and a lot of the problems that it had early on are fixed. So I've seen relatively complex applications of Shiny dashboards. So I would think that it's ready to actually be used with some reactivity. So let's have a look at some really our first inputs. So we've got our dashboard with header, sidebar, and body. And now we can create a sidebar. So just to keep things a little bit more manageable, whenever we're creating actual inputs, it might be a good idea to create an object first. So sidebar is an object that takes dashboard sidebar, and we create a text input that will say enter your name, and value at first is my name. You can pick a different default. This is just the default value, and you can let people decide what they want to return to you. So this is going to look like this. We've got a sidebar now, or we've got an element in the sidebar with some text input. Enter your name. This is the label that shows up here with a default value. So at the top, text input, we give this thing a name. So the name of this piece is actually name, and we're going to refer to it as name when we try to work with it later. So this is an ID value, and because it's an ID value, any ID value is going to be turned into an R object. So because it's going to be an R object, all of the rules about R objects are going to have to apply to the name that you pick. So you can't start with a number. You can't have, or you should not have, a space in this name. That's going to make things really tricky to work with. And just try not to use too many special symbols because it's going to be really awkward. So beyond that, you can just name it. So the name comes from you. You just have to have a unique name. So you can't have multiple input objects share the same name. Otherwise, the system can't distinguish between the two different, or between multiple different inputs. Okay, so this thing is going to be important and we're going to come back to it. But for right now, it's just the name of this text box. So let me show you more inputs, and then I'll hand over to you and you'll get a couple minutes to actually do something. Okay, so we've got input widget. So we've talked about one. That's the text input here. And you can see that there's a whole range of other input widgets. we've got buttons, single checkboxes, so they can be turned off or on, checkbox groups where you can select multiple things, dates, date ranges, numeric inputs, radio buttons. Difference between checkboxes and radio buttons is that you can only generally pick one of these radio buttons, but you can pick multiple choices here. There's select boxes where you can pick a choice out of multiple given choices, a bit like a radio button, but with a different format and just generally text. So all of these are so-called input widgets. What all of these input widgets have in common is they correspond to a function of the form widget input. So this is those little X's, they're supposed to stand for whatever it is that you want to input. So in the first example, we had text. So the corresponding call was text input. So that's the one here at the bottom. And you can see all of the different widgets lined out nicely in this first column here. And the second column is showing the name of the function and then also the setup of the different parameters. So most of these input widgets have a form where we've got an input ID, a label, so the thing that's going to show up as some minimal text to the user. And then most of them also have a value, but not all of them. The first two are non-optional. So in every input widget has an input ID and a label. And then depending on the widget, we've got other widget specific parameters that are listed here in the back. This image here is part of the Shiny cheat sheet. So the Shiny cheat sheet is one of the fabulous set of RStudio cheat sheets. If you haven't found them, make sure you follow this link. There's a lot more of these kind of cheat sheets. And these cheat sheets are usually a front and a back of just a US letter sized front and back sheet that summarizes all of the essentials for a particular package or for a particular working approach. So here we've got an excerpt from the cheat sheet that lists all of the available inputs with a visual of how these inputs look like, as well as the name of the function that corresponds to that. Okay, so I'm going to hand over to you guys. So this is your turn. Have a look at the file O2B minimal. I want you to modify the sidebar to go from just one widget to two widgets. So create another widget that has this form here. If you're feeling advanced, go and add a bunch of other inputs and also figure out how to give this app a title. So I'll give you until 11 o'clock, so 8 minutes, 7 minutes. Did you all manage to get the app to work? Sort of? Let's have a look at this. Oops, that was my alarm. Okay, so to be minimal, looks like this. We can run this and it will create the dashboard. And we can enter the name in the sidebar. Well, we can, it doesn't do anything yet, but we can at least interact with the app for right now. So let's include another widget. Have you figured out which widget was pictured on the your turn? Select, right, good job. Okay, so select input is what we're looking for, and I really love the RStudio little help. So this select input has an input ID. We need to give it a label, and then we've got different choices. So let's give this a name, state. Enter your state or select your state. And then we've got different choices. And we can just list the choices in form of a vector, so of characters. So we can, let's go alphabetical: Iowa, Oregon, and Virginia. We can, but we don't have to give it a first selection. So Virginia was first. So let's make Virginia the default and run this app. You can see how this select input is now showing up in the sidebar with that little bar. Virginia is the selected state right now. Clicking on that little triangle gives us a way to select something else. All right. So this is, what was that okay? So did you figure out how to put in a title? The title is actually part of dashboard header. We can write out our title. If in case dashboard sidebar is not found, we need to make sure that the Shiny dashboard library is loaded. Dashboard, yeah, Shiny dashboard is a separate package. So when you find the help for that, you can see that dashboard sidebar is part of the Shiny dashboard package. So in case something like that happens, you can use the double question mark and it will create an overview for you in R of all the things that sound like dashboard sidebar. There we go. And you can then see the first part is the package separated by colon, and then you get the name of the function that you were looking for, or the object that you were looking for, and that hopefully tells you that you need the Shiny dashboard package. Okay, so just in case you want to get super ready for everything, you can also run this first R file 00 setting up. The first couple of lines just talk about Shiny, but then the next set of lines install all of the packages that we'll be touching on today or tomorrow. I hope I got them all, but I think I did. So you can just select all of that and run it, and that will install all of the packages that we will be using. Okay, so Shiny dashboard has to be activated, and oh yeah, we were at the title, so let's just save this app and run it, and you'll see that, oh, here we go. Here's the title, so my app. In the browser, you'll also see my app showing up in the top left. And also, at least if you don't have too many windows like I do, you'll also see my app as the name of the window that you're currently looking at. So here, window, my app. If we change this, this is going to change with it. So let's hop back into the slides actually. Okay, so we've got a way to check, to include more inputs. Now let's have a look at the outputs. So outputs usually go into the body part, and pretty much all the output functions have the form kind of output followed by the camel case output. And the value, the parameter that is the most important is we have to define a name for this particular object. So we have to give that object an ID. The output itself can then be a table, plot, text, pretty much anything. So there's, again, oh, come on. There's, here we go. Again, the Shiny cheat sheet has a little table of possible outputs. On the left, we have, again, how these outputs look like. On the right-hand side, we've got our definition for how this output is being defined in the UI. And then we've got a separate piece. We also have to explain how this output is actually being created. And that usually takes the form of render. So render object, here render plot. That is a piece that's going to go into our server, onto the server side. So that means that we've got a piece where we define. So let's just assume that we want to now define a plot. We want this plot to show up in the body of our dashboard. So plot output, we define it to show up here. We give it the name myPlot. And then in the server function, we have to define how this myPlot object is being created. So you can see here, myPlot is now a part of output. Output is a list of objects, and we define by creating this plot output, by including this plot output, we create a myplot piece in output. And in order to create this plot, we call the function render plot. So again, camel case, render with an uppercase plot. And all of these render functions are a little bit curious. They are not your typical function. They are functions that that take a whole bunch of commands. So they take several functions or several lines of commands, and that means that we have to bind these several lines of commands together, and we usually do that with the curly brackets. So that's why all of the render functions are usually written in a form open parenthesis, open curly bracket, then we've got some sort of body, and then we close that body with a curly bracket and a parenthesis. That's the end of that render function. So what do we do in that render plot? We create a ggplot, and we create a title where we take the name from the input. So you can see here, text input was called name. That creates anything that has an input, creates an object in the input object. Input $name is going to be, by default, it's going to be just my name, Heike. And then here we've also got an input called state. That's what we just created in the last your turn. And that both of these are going to be munched together in this sprintf. So this is just a printed format where we take the first character and plop it in here, and we take the second character and we plop it in there, and what comes out of this is a character string with these values included here. So this is just cosmetics. So this is going to create a title. And when we're done with that, we get a function, we get output like this. We've got our sidebar with our choices. We've got a plot. The plot at the moment is completely empty, but it has a title, and the title is pieced together from the information that we gave to the dashboard, as in this case, Heike in Iowa. So this is Heike's plot in Iowa. It's completely empty. Doesn't remind us at all of Iowa, right? I shouldn't joke about this. Sorry. So let's hop into our studio and actually run this. And I want you to run this. So start with O2, so 2D minimal. That's where we've already included an actual plot. I can actually show you. And what we want to include as well is a table below this plot. So we want to add another output and show this underneath the plot. So let's hop into our studio. To C contained the solution, if you want to call it that way, of the previous your turn. So now we start with 2D. Let's just see what this looks like. 2D has a sidebar. And the plot. Oh, okay. So the plot is still empty. So there's actually two pieces to this, your turn. I want you to modify the plot to include data from the empty cars data set. So empty cars is part of ggplot2. Oh no, it's part of data sets. So empty cars is a part of base R. So just show some picture that pick some variables that are suitable for this plot. So some x-axis, some y-axis with points. And also add a table that shows here the first 10 lines of the data so that the new Shiny app looks like this. And I'm going to give you another 7 minutes. And we can come back and talk about this. Okay. Okay, we'll get to the data table. Okay, so let's start with the 2E file so that we're all starting from the same thing. Okay, so I think the, oh. Two E is too far. 2D is what we want to have. Okay, reload. And 2D, okay. Let's run this again. There we go. Okay, so this is the plot, the part where we're starting. We want to make, so first piece, we want to make sure that we actually show something on this plot. So we want to involve this empty cars data set somehow. So we pipe the empty cars into ggplot2. I like to use the pipe. Let's make sure that I can use the pipe. dplyr should help me with that. If you don't want to use the pipe, that's perfectly fine. Then you just can't use this nice thing here. So ggplot, we specify something for the x-axis. How about displacement again? So displacement, y is miles per gallon. And now we also need to include a layer for the points. That should be it, right? So that, let's run this piece. dplyr should actually run, same as ggplot2. Then we can try out this piece. And that, yes, that gives us a plot here. Why can't we use the next line? So in our regular R console, we don't actually have access to this input. So we have to run the app and just rely on the app knowing about the input and pulling the input from our widgets. So whenever we change something in our widgets, you can see that the plot updates itself. So if we are using an input element in a render function, then as soon as the input changes, a redraw or a re-render is being triggered in the server output. So that's the reactivity in Shiny. We trigger this input, using an input element in a render will trigger a redraw. So let's now include a table. So this is table output. Oh, I'm very inventive today. My table. That's going to be the table. So now I need to figure out how to draw or create this table, my table. And the trick is that we need to use the same, so the output definition and the render function go hand in hand. So here we've got a table output, which means that we need to have a render table, and it's a render function. So the open close parentheses are followed by an curly open close. And the only thing that we need to do here is we want to show the first 10 lines of empty cars. There we go. That should be it. Let's rerun this. And please, yes. It did actually work on the first time. So here we've got our Shiny, I'll open it in the browser. We've got our Shiny app. We've got the plot. We've got the 10 lines from the table. It doesn't look particularly pretty. We're going to have a look at that after our break. But here's the code for this particular your turn. So thanks everybody. This was the first half of our Shiny session. Now we're going to go and listen to the brown bag lunch. Have fun, everybody. And I'll stay on the chat for a moment longer to answer questions.
Heike, could you just go once more over how did you create the table? So is that render table a part of the server function?
Let's have a look at it. So the only thing that we had to do in the server is to call render table. Render table is going to take a data frame or a matrix and make it into a table. So that's built-in functionality of the render table function. We can have a closer look at that render table function in the R help.
Oh, actually, I was trying to ask, is that output my table inside the server function? I'm sorry.
Oh, the output?
Yeah. Yes, so it is inside the server, right? It is inside the server function. Output my table.
Yes, output my table is using the the output ID of our table as we've defined it in the sidebar, no, in the main body.
Okay.
So we've got the dashboard body, we've got a plot, comma, don't forget this comma, this is really crucial. And then we just create a new table output and we call it my table. So that's the table, the output ID of this table. And that creates a slot in output, a slot in that object output called my table.
Got it. Thank you very much.
And in there we create that table. Yes. Okay. All right. Welcome back, everybody. So for the next 1.5 hours, we'll look more into Shiny, into more reactivity, into slightly fancier outputs. And then hopefully we can also think a little bit about what kind of dashboards we want to build tomorrow. So let's get going. The app that we last looked at was this one, where we had our sideboard, sideboard on the side, sidebar on the side, a plot in the body, and then the table at the bottom. So at the moment, this table is not particularly reactive to anything. This table just spits out the first 10 lines of the empty cars data. So what we can do to change that is we could add another input. So let's say that we've got an input that tells us how many values we want to show. So let's call that sample or size, or I don't know. So by default, we want this to be 10, but we want to now include another input. So we would go up to the sidebar, dashboard sidebar, include that input, and let's include a slider input. We've called it sample, so we need to give this slider input the input ID sample. And so when you hit tab and you're inside a function, you get, again, help from RStudio. So we want to have a label. The label should say something like sample size. And this slider widget is supposed to show an option between the minimum number of sample, so let's say 1, and the full data set of empty cars as the maximum. So let's have a look at the other options in slider input. So minimum, that's going to be our 1. Maximum of, we could say, the number of rows that are in this data set. So we can include things that are not just numbers, but we can include functions here as well. Alternatively, we could just set this to 32. That's the number of lines that empty cars has. Is that all? No, not yet. We want to also set a default value. So that's the initial value of the slider. And I said that we wanted to have 10 to start out with. So let's do that. We've defined our slider input. And when that slider input changes, our table below the output plot should change with it. Let's see that that works. So we've got our widget here, 1 to 32. It's set by default at 10. Let's see, 2, 4, 6, 8, 10. That is actually correct. Let's see that we can have fewer values. So you can see how the table actually reacts to our changes. And here we've got the full table with 32 rows. So I said before that this is not particularly great formatting. We can do a lot better. So let's have a look at how we can do better. You've already seen the package DT for data tables. And the really nice thing about Shiny and this whole R development community is that packages outside of Shiny will provide functionality that allows us to include certain pieces into Shiny. So the data table package that you've seen earlier this week or last week has two functions that allow us to render a data table. And data table is much, much fancier and allows us a lot more interactions with a table than the space table that you've just seen. So the functions that we need here are called DT output. And you can see here, DT followed by a camel case output. That's how we define the output in our body. And then render DT for data table, that allows us to call the rendering function for a data table. None of the other functionality has to change. So we can just switch out the user interface, change the render function or the name of the render function, and that will give us a Shiny app that looks like this. There's a lot more functionality that you can call or that you can make use of with DT, like formatting of the rows. You can redefine the headers. You can include or restrict the search function here. You can have additional filters on these variables. So you can just follow this link to the RStudio GitHub page for DT for data table. So let's have a look at this in R. We're at 2G. I really shouldn't be calling this minimal anymore, but that's how it started out. So let's hop into RStudio and have a look at this data table. So it's in 2G, in file 2G, we've got Shiny dashboard as package dependency. We've got ggplot2, that's for the plot. And now we're adding library DT to that setup. So let's run this and then we can have a look at the code. So this has also the widget for selecting the sample size. And you can see how we've got the 10 entries here. We've got the table. The table is now sortable. We can sort from bottom to top or top to bottom. We can sort by displacement. We can search for individual values. Oh. There we go. When we change the sample size, so here we've got now the full data set. We still only see a couple of lines, and we can now move through this table in a much nicer, with a much nicer interface. So we get all of this essentially for free. So let's stop this and have a look at the code, because You might not believe me that it's actually for free. So let's have a look at these changes. We've got the body. Nothing changed in the sidebar. The first change that we've got is in DT output, is in the body. We now have DT output instead of the table output. So we've just changed the way that we've just changed the user interface. Instead of just a plain table, we're now using a DT output. And this is the function to define the DT output. So the second change that we need when we change an output is a change in the rendering. Renderings happen in the server. So here we've got our second change. Instead of render table, we're now calling render capital D, capital T, and nothing else has changed. So if this is not for free, I'm not sure what is for free. You can see two mini changes make have quite a bit of impact on the Shiny app. So what would be really nice now is to be able to select something in the table and see the selection in the window, in the plot. And that's actually possible. So that is the next your turn. What I would like to have is functionality that looks like this. We select a row in the table that highlights this row with the light blue, well, lightish blue. And here we've got dots that are bigger. How does that work? We've got an input that is defined automatically when we use DT. The input is called the same name as the table. So this would be my table underscore rows underscore selected. in this example, the selection that we get back is a vector called 1 of integers consisting of 1, 3, and 4. Not the 2, nothing beyond that. So that gives us all of the index values for the for the data frame. So we can now use those indices in the in combination with the data, select a subset, and put a layer on top of this plot that shows bigger points for just those values that are selected in this table ID row selected. Does that make sense? I'll give you another 7 minutes and see how far we come when trying to solve this your turn. So 7 minutes, clock's ticking. Did this work? Did it almost work? Or did you just run into shiny errors all over? Okay, let's have a look into this. So I believe that we're starting here in H. Is that what I said? All right, so what we want is we want these points to show up in a larger size. So this is where we're starting. And this is already giving away the solution to a large degree. Okay, so let's get rid of that for a moment. So we can just think of our problem as adding yet another layer to this ggplot2 code. And I'm going to implement something that's not going to work because I think it's really important to see how we can get ourselves out of that. Because most of the time, like 95% of the time, Shiny apps don't work until you finally get them to work, and they work for a beautiful 5 minutes. So let's have a look at this additional point layer that we want to create. So it's the same x-axis, the same y, or the same things mapped to x, the same things mapped to y. We want to make this point size much bigger. So size is usually 3. Let's make it 5. And we should call it size. There we go. And the idea is that instead of empty cars, the full thing, we're now using a slice operator where we just select by the number of rows. And what we're selecting on is my table underscore selected rows. So so when something's selected, we want to put that into this layer at a bigger size. Let's run that. And we get an error that slice expressions should return indices, positive or negative integers. And at this point, we probably give up instead of hitting some number. No, so nothing really happens. So it's just mad with us. So what do we do in this case? So one way to work with and debug a Shiny app is to use the statement browser. So I'm putting a browser statement just before we render the plot. And what's going to happen is we're going to start the app, and then the app's going to interrupt. It's still going to be there in the background, but we get control back in the console at exactly this position. So we can check what's going wrong here. So we run this app again. It's starting up, and at some point we're going to jump back into the browser. So now we jump back, and you might be able to see we've got this traceback over here, but more importantly, we've got our console back. So if I'm now typing into the console, I've got a reactive console, and I can check what's in this my table rows, no, selected rows. And there's just nothing there yet. So that means that as long as nothing's selected, this thing is null. So we need to somehow deal with the situation that initially this thing is not even there. So let's change our code, and that's the beauty in it. We are still in the browser window, but we can now change our code. So I'm going to create a new object called GG, where we get the first part of our plot in. And if not is null of this object, we're going to hop into this creation, into this condition here, and we're going to add to our plot. So we are going to add another layer. And once we're done with that, we're going to return the object GG back in our Shiny app. So I'm going to stop the browser now. You can stop the browser by either hitting this square stop button, or you can include a capital Q for quit. That's the old way of getting out of the browser. So let's just comment out this browser statement and run the app again. Let's see whether that works now. So we've got our plot back. Let's see whether it behaves like it should. We're selecting something, but it doesn't seem to show up here. So what else is going on? So now we're hopping back into the browser. And what it turns out to be is that Shiny doesn't like this input inside the slice. That, I think, is a dplyr mini bug. So let's hop into our GHI. Let's hop into file I. It has the same setup, but we're saving this output as a vector. We're now testing on the vector, and we're creating this file, this layers in exactly the same way. So now that we run this, we click on a row and it actually shows up. What might be a little bit disconcerting is if we select a second row and nothing happens. But if you have a look at those two values, displacement is 160 and miles per gallon is 21. These 2 points are actually falling on top of each other. So we're selecting 2 and we just can't see that we've selected 2. There we go. All right, so we can make changes in DT and use a lot of additional DT functionality. And besides using the browser, we can also put in print statements. So print statements will print out pieces in while the app is running. So for example, we can put in a print statement or a cat statement in the app. We run the app, and I'll run the app not in the browser, but just here in the RStudio window. I'm selecting something, and you can see how the printout is showing up in the R console. It's a little bit unformatted. So 3, 4, 5. So all of the numbers are just being pasted into the console, I probably should put in a line break someplace. So print, str, all of these information gathering functions are really good to get an overview of what what input or output actually hold at any given point in time. Okay, let's get back into Keynote because I want you to see yet another way to fancy up our app. So you might have seen Plotly already. Plotly allows us to take a ggplot2 definition of a plot and create interactive elements around it that allows panning, zooming, selections, info text. So the functions are again, there's just again 2 functions that we really need besides creating the Plotly output. But if you've got a ggplot2 object called gg, you can call Plotly, you can make this a Plotly plot by using ggplotly, the command ggplotly on this ggplot2 object. Once we've got ggplotly working, we need to redefine the output. So instead of plot output, we use a Plotly output. And then instead of render plot, we use render Plotly to define the interactive plot. This is defined in 2J. So let's have a look at how 2J looks like. So besides DT, we now also call the Plotly package. We've changed in the body, we've changed the command from plot output to Plotly output. And the other changes are in the server functions. We've got an object called, we return an object ggplotly of this gg object, and we render it with the command render Plotly instead of render plot. So conceptually, the same thing is happening. We just need to adjust the exact function calls in order to get to a Plotly output. So how does that look like now? And just to put a little bit more color on here, we've used the number of cylinders as a factor variable to color by that. The plot looks almost like a regular ggplot plot, but once you hover over it or once you click on it, you can see that we've got a whole set of menus up here. The legend's also showing up a little bit weirdly, but that's something that we just have to take when we use Plotly. What we get out of it are things like this. We hover over a point and we get additional information. That just happens automatically. What also happens automatically is we can zoom by clicking and dragging into a window. We zoom into that. Double clicking is going to get us back out. Once we've zoomed into a window, we can also pan, oopsie. We can also pan by switching to panning. Here we We switch to pan, and now we can zoom. So this is in particular nice when we've got a very dense plot where we want to first zoom in and then change the location in some way. Here it doesn't necessarily make a lot of sense. But what's also really neat is the legend on the right-hand side is interactive. I can select and deselect individual levels. By just clicking on them, you can see that they are grayed out, and then they are also just disappearing from the window, but the scale doesn't change. So we can still keep track of all of these missing points without having to adjust for a changed scale. All right, so this is Plotly. And we didn't really have to change that much. So do you have any questions at the moment? Oh yeah, we've got the package Plotly being used, and in case library Plotly gives you an error message, make sure to install Plotly, the package. You do that with install.packages Plotly. You can also run the setup file 00_setup. Okay, so then if we don't have any questions right now, let's have a look at a bit more reactivity. So essentially, you can think of reactivity just like Newton's cradle. We've got an action and then a reaction happening. So it's pretty clear that this little ball is providing some input when it hits the middle balls. The middle balls don't seem to do anything, and yet they transmit, they conduct the energy to the other side where a reaction is happening. So the reactivity works essentially the same way. We've got sources, so the user is putting something in. So any kind of input widget is a source that triggers an action. And so far we've only seen direct reaction. So any output is called an observer. That's where the flow of the interactivity stops. So far we've gone straight from a source to an observer. What we can now do is we can optimize our program a little bit and also include conductors. So conductors take changes from the input and they pass changes on to the output. And you can see here, this particular conductor is moving things to 2 observers. So usually we're using conductors to try to optimize some functionality. So rather than repeating the same kind of filtering process, for example, we move that functionality into something like a function, so into a conductor. And the conductor is being updated only once, and then it passes the results on to all of the observers that depend on that. So let's have a look at conductors. So essentially we're going to deal with 2 conductors. We are going to deal with a reactive expression and then also a reactive event. Reactive expressions are really the archetypical conductor. We take functionality in the app that's there multiple times, and we isolate it in just a single place where we evaluate that. So we do the calculations only once, and then we pass on these, the result of those conductions into the observers that depend on it. We'll look at reactive events later, but essentially you can think of reactive events as being reactive expressions where we have to explicitly say, now do it. So they're even more laid back than those reactive expressions. So the main thing about reactive expressions is this laziness and caching. So what that means is reactive expressions don't change until a change is actually requested. So they're only evaluated on demand. So they're going to stay lazy until somebody pushes them out of the lawn chair. So there's a request by an endpoint that something should be done. And then once they've evaluated their calculations, they cache the evaluations. So they keep track of the current situation and just pass on the current situation to all of the observers. In terms of code, a reactive expression looks like this. So instead of render something, we write in the server reactive, and we use the same kind of weird format of opening parentheses and followed by the open curly brackets. So we've got an expression enveloped here between those curly brackets. And we store this in this reactive value. Reactive values are then being called in other output using the command, using their name, followed by opening, closing. So they really look like a function. With a reactive event, we use the command event reactive. And you can think of event reactive as being an observer that, no, not as an observer, a conductor that needs a real push. So usually the push of a button. So if this action button changes, then this event reactive is going to actually respond. Beyond that, it's these reactive events are exactly the same, look exactly the same as reactive expressions. Okay, so let's have a look at this in an actual function or an actual example. So we're switching from the minimal examples to submission. So let me run this submission Shiny app a couple times. So 03 submission. We're back to a fluid page, but just because, just for change, so that you see that nothing really has changed. We've got a submission form where we can enter the favorite day of the year. Okay, so maybe July 1st. We submit and we get a reaction to that. I'm sorry, the reactions are sort of corny. We can pick other days of the year. Why not May 6th? And we get a text that reacts to that. And we also get a visualization of when our favorite day of the year is. So who doesn't like Thanksgiving? That would be somewhere here. I'm not sure about Thanksgiving this year. No, that would be Black Friday. Let's guess. 26th, is that about right? Help me, chat, in case I'm wrong. So in my family, everybody likes Thanksgiving. So let's push the submit button a couple times and you can see how the counter for that day goes up, and there's 148 days until Thanksgiving in case you monitor when to buy Christmas presents if you buy Christmas presents. It's only 177 days, so time to panic. At least I usually do panic at this point. Okay, so we can see this is a really simple submission form, and we react to this with a plot and some text. So it doesn't, I hope it doesn't look like it's that much of a deal, a big deal in terms of the reactivity. So the next couple of minutes are probably going to be a bit surprising. Let's have a look at what's actually going on in the code. So we've got this fluid form or fluid page. So fluid page is again just user interaction. So we've got a bit of text, we've got a text input, we've got a date input where we start with a default of today. We've got this action button that has an ID of submit and a label of submit. So we push that. We've got an output, and the output doesn't show until we actually do something. So we've got a text output that says, that's called greeting, and then we've got a plot output that says histogram, even though it's not actually a histogram. My names are really awesome. Sorry about that. I didn't go back and check that. Okay, so then we've got the server function, and this looks complicated. Let's jump that. We've got the greeting here that hopefully looks less complicated. It's just nasty. So what we do in this greeting is, oh, it's also complicated with this event reactive. Let's jump that too. So what we get here is a histogram, or a dot plot actually. So we call render plot with ggplot. We've got so we first just create this empty plot. If this reactive expression has more than 0 rows, we also add a dot plot. Okay, so we actually have to have a look at what's going on with this reactive expression. So rval favs is a reactive event that listens to the submit, to input submit. So that's the action button that we hit when we hit submit. And what it does, it checks if this file exists, favorite days. If it does, it reads this file. Otherwise, oh no, if it does not, it creates a data frame with the current input of name and date. If the file exists, it reads that file in and then attaches another line with the current input name and input date. So at the end of this if statement, we've got an object called favs, and we make sure that the date component has actually is actually recognized as date with year, month, and day in year, month, and day format. That's what this lubridate function is doing. And we write out the new favorite favs data set. So in case you were wondering, here at the end of those .r, at the end of those R files, we now also have a CSV file with all of those favorite days. We can click on that and open it. And you can see here name and the dates that were clicked. So Thanksgiving features pretty heavily here. Christmas ones today, and this May 6th. So all of the pieces that were included are now captured in favorite days. So this is a side effect of this reactive function. We create, we read in existing favorite days, and we create a new file. We also create this object here, and we return the object back out of this function. So this function has a side effect, and it creates this object favs. So if this object favs, our val favs, has at least one entry, we also create this layer in the ggplot2 plot of the dot plot. All right? So the other piece happened also on the submit, hitting the submit button. So it's also an event reactive. It hits the we hit the submit button, and then we evaluate this code where we calculate the difference in days between today's date and the input date. And then we've got different greetings depending on that date. We paste this together using the name that's included and then the message that was created in this lengthy if statement. Does that make sense? So even though this app looked like not that much, there's quite a bit going on in these server statements, in this reactive statements. Okay, so I'll let you play with this app for a moment. So we're revving up for the next, your turn. What I want you to do is go into this app. So it's o3submission.r. And we've got all of these black dots. There's a package called Color Picker that implements a color wheel as an input widget. So that looks like this. And what I want you to do is include this input so that we allow the user to pick a new color and change the elements in that dot plot. And that's actually the fill color, so be careful. We've got a fill color that's the inner of the circle, and then black for the outline around the circle, so that you're not tripped up by that. So just include the color with the color picker. What you need to figure out is how to actually, what functions to use. So you get a bit more responsibility on your plate. Have a look at the package Color Picker and see how the color input is actually implemented. And I'll monitor the chat if you can't find anything at all. I'd be happy to help out. 7 minutes it is, and off you go. All right, that was the timer. How did that go? Do you find color input? So with all of these Shiny apps, what we're really looking for is input and output functions, as well as render functions. So we can have a look at O3B and just run that. But one of the things that I would like you to have a look at is how it looks like when we've got the color and we change the color and nothing really happens. So that's usually a little bit disturbing for the user. So let's have a look at the solution. We've got the color input, and then we read the color input as we're creating that dot plot. Fill is input wheel, so that's the new color. So let's run that. So by default, we've got some sort of gray color. Let's find a really garish green. There we go. And nothing really happens until we finally submit something. And the points show up. And see how the points actually use our previous input. But what would be so much nicer if we only get the color choice once we've seen the plot. And when you think about when we see the plot, that happens after we hit the submit button for the first time. So one way to go about that is with a so-called conditional panel. So instead of, so first of all, I think the color input works a lot better if we have this at the bottom below the histogram. But that doesn't change anything. That's just cosmetics. But what what I think we should do is what we should include is be a little bit more considerate of our user. And one way to do that is to use the command conditional panel. So conditional panel is has a condition, and only if the condition is fulfilled will the color will the elements in this user interface, which at the moment just consists of the color input, those will be shown. So if the condition is false, we're not going to see that color pick, that color wheel. So that doesn't show up. And we don't have that functionality. We just, hey, that's not supposed to happen. Okay, so this showed up. It wasn't supposed to show up. So usually this this condition takes the form of some evaluation. So the evaluation that we want to include here is we want to evaluate the value of the submit button. And any action button starts with a value of 0. And each time that we hit this button, its value is going to be increased by 1. So we can keep track of how often the submit button is being pushed. Whenever we restart the app, it's at 0. So we want to only see this color input when the submit button is greater than 0. And this is a little bit unfortunate, this dot here. For those of you familiar with JavaScript, this is a definition in JavaScript. So once in a while, Shiny gives us a hint of how ugly it could be. So this condition is being evaluated in the HTML side. And that's why we need to use JavaScript definitions. And on the JavaScript side, we will have an object input. And in order to get access to the sub-object submit, we need to use the dot to get from to get at the submit piece of input. So if that submit piece of the input is greater than 0, we want to show the color input, otherwise we don't want to show it. Let's run this again. And this time I'm going to go all the way down. So there's nothing. I'm scrolling and I keep scrolling and there's just nothing there. There's an empty plot, but there's nothing showing up below. So let's see whether this is working the way it's supposed to. And by default, we've got a color of gray. We can change that color to something else that is going to update the plot. So it's still functional as it was before, but it only shows up once the plot shows up, so that its functionality, so its action or the reaction to making a change in here actually has a meaning within the context of this plot. And we don't have to make a change and the user is questioning what this change is supposed to do. So I like conditional panels. Conditional panels will show up in any more complex Shiny app. So try to wrap your head around the stupid definition of the condition. It's essentially a true-false statement. And only if this condition ends in a true statement will we add any of the widgets that are defined here. So in this case, the color input. Does that make sense? Any questions? Okay, so let's have a look at layout a little bit more. We've talked about conditional panels. So one of the advantages of the dashboard is the body of the dashboard is laid out in a grid. So we have a pretty good control over this layout. By definition, it's 12 columns wide. So it's not defined in pixels or in inch. It's just 12 columns. So from left to right, we've got 12 columns. And then we can define additional structures by using so-called boxes. By default, the boxes are of width 6. So we can stuff 2 boxes side by side and give some structure. So the good thing about boxes is they are just a frame. So we can draw a frame around anything, and that means that these 2 things are now, by definition, connected somehow. So using boxes, we can introduce a lot of structure. So here we've got a box here we've got 3 boxes, a box with width 12, and then 2 boxes with 6 columns with a width of 6 columns each. And you can see that these boxes have different heights. In order to make the same height, the boxes the same height, we can use the height parameter to make them a specific height. And that's where things are a little bit funky, because the height is specified in pixels. So width is specified in the number of columns that they cover, whereas the height is actually specified in pixels. We can also use so-called statuses. So boxes have a status parameter, and the status of each box is shown as this colored line along the top. There's 5 different statuses predefined in Shiny. They are called valid statuses. So if you use help valid statuses, you're given these strings. So they are primary, success, info, warning, and danger. So the primary is a dark blue line. along the same color scheme as the Shiny app itself. Success is green, info is light blue, orange is a warning, red is danger. So you can try to use this color scheme if you want to give more feedback to a user. When they actually have to do something, you might want to use a danger symbol, or if you want to warn them, you can use orange for that. We distinguish between a row-based layout. So that means that all of the boxes are aligned at the top, and we have to set the heights to be the same. Or we can have a grid-based, a column-based layout where we use the command column. So the row-based layout is triggered with the command fluid row. And then we can also mix fluid rows and columns. I would stick usually with a fluid row, so a row-based layout. You can, I think, get to any other layout by using column in between. So column-based layouts would define a column of a specific height, and all of the boxes are left aligned, so you have to set the width to a certain value, and those boxes are then, that will align the boxes by width as well. In order to get to a bit more fancy dashboards, we can use so-called tab sets. So you can see here on the left-hand side, we're using the sidebar menu to set up a couple of links, essentially, that allow for quick navigation. So by clicking on dashboard, here we see this content page. By clicking on cars, we activate cars, and we get the content of what we call the O2 minimal dashboard. So we can, and the only difference is here, we clicked on just a part of this dashboard. So this is part of the file 05 tab sets, and I can quickly talk you through this code because it's really not that terrible. So the main change that we see is in the sidebar. So in the sidebar definition, we now define a sidebar menu. Sidebar menu is going to create these little boxes. You can see the active box has a blue bar on the left-hand side. So we've got essentially a list of menu items, and we list each item with the command menu item. We give this a name. So this is the label that shows up here. And we also give this a tab name. So this is similar to the IDs from before, except now they're called tab names. And if we want to, we can use any element of the font awesome as an icon. So here, when you Google for font awesome, you can see all of the possible icons. So you can go totally nuts over adding these icons to dashboards. It just gives a nice touch to it. So here we've got a dashboard, and then we've got a second menu item called cars. We've got a table layout for an icon, just these squares. Our tab name for this is very inventive. It's just lowercase cars. We can use badges. So here's just if you want to make the user aware of a change in in the app. You can use here this badge label of new, choose a color. So these menus can carry some information. So we define this menu in sidebar, and at the moment this doesn't do anything. So this is just a menu. So it's just layout, it's just user interface. Where the options come in is in the body. We've got corresponding tab items. So one tab item corresponding to each one of these tab names. So in dashboard body, we've got tab item dashboard. And here we've got this, so this is actually shortened. So don't try to run this code. The ... dots are just a shortcut of all of the boxes that were defined. So we're using a fluid row layout. So we can actually change between different layouts in these different tabs. And here there's all these boxes listed. Then we've got a second tab item down here, tab name cars, that corresponds to this second menu item. And we've got our plot and the data table output. So this looks exactly like the sidebar looked in our previously in our solutions. So these are the only things that have changed. It's all the user interface. So tab sets are just user interface. There's nothing that has to happen on the server side. This is just fancy HTML going on in the back, but there's no actual computer power needed on the server side. So the server side hasn't changed. So this is the point where I wanted to start a really big U-turn, and time doesn't really permit for that now. But what I want you to do is I want you to get prepped for tomorrow. So we're going for option 2. I want you to find a couple minutes this afternoon to get together with your team and start by hand drawing a sketch of what you want your dashboard for your project to look like. You can incorporate some of the tab items. So think of a list, a menu on the side, on the left-hand side in the sidebar of the different pieces that you want to show. Sketch out each one of your tab items.